Okay, I'm sorry, I'm back. So hopefully this is online now. Yep. And we're back to measuring the 1 mega ohm resistor. So I'll just write down the values for each range on the HP meter, and then we can compare on the same values on the Advantest meter. And I use NPLC 100 and autozero enabled, and offset compensation is disabled. There we go. Should be nice and clear. And I can go one range up. And let me write down the value. Now we can go 100 mega ohm range. And now I can go 1 giga ohm range. So here's everything. Everything's stable. We get our 1 mega ohm, and now we can do the same test. Let me show you recorded values. Here we go. We can do the same with the test meter. So I'll just take this resistor out, connect to ADCMT. There we go. Now select 2-wire mode. And this is what we get. The first off, it's very much off, and I calibrated actually this Advantest meter using the external cal just a couple weeks ago, and it shouldn't be that much off. Anyway, we can record the value. It's 999,804, 805.36, and it's slowly going up. And going down, so I'll call it 999,80555. We can go 10 megohm and check the configuration. So still have 110 PLC, same as HP meter, 8.5 digit, normal measurement, range limit, we don't touch that, high power, protection is on, we can try disable protection to see if that have any effect, and it does not. So we have about the same value. We can try offset compensation, which should not do much on this high range. Now it's set. And the reading is even worse. It's actually become lower than its normal measurement mode. So we will disable that. And we can go 10 megohm. Range up. You can see the VFD brightness is very poor. And still didn't get the correct answer from anyone, any of the owner of such meters, if the high voltage drive should be AC or DC voltage. Because based on the measurement, I have the AC voltage here, around 40 volts AC for the VFD display. I'm not sure if that's correct or not. So on the 10 megohm range we get around 999,785. Now we can go even higher, 100 megohm. And it's indeed even more off. We can try go max range, 1 gigaohm. And on 1 gigaohm we're actually getting higher reading. Call that an average, maybe 1003. So let's go back to 1 megohm, down, down, down. And we're back to low readings. So now we can calculate the error. So I'll use HP values as a reference. So let's see how much error we have. So on the 1 megohm range we have minus 195 ppm, which is way out of the spec. And on the 10 meg range we have 785, around minus 250. And on 100 megohm we have whole 1000. And 1 gig we have plus 300. So this is the error of my Advantest 6581 in its current condition. So there is one more test we can try, is to measure the difference between 10 volt positive and negative polarity. So for that I'll use the second meter, HP as a reference, so we'll connect the reference back in. Let me use the same cable. I think it will be better. So we cannot blame using different cables cause the error. There we go. So here we have 10 volts. Let's just set some quick settings. 8 digits. And the reference is powered by battery. So we can record down the value. Plus 10 volts. Is plus 10, 0, 0, 0, 0, 0, 41 volts. More like average around 40. Now I can reverse the connector. And we should get very small error. With reversal we get 0, 0, 0, 1, 1, 9. Well, around 20. So the total error from the cable reversal is less than 0.2 ppm. Let's say it's 24. Yeah, let's call it 2.5, 2.4 microvolts difference, and that translates into 0.16 ppm difference. We can indeed reverse again. Just to make sure. Yep. So now we can do the same test for the Advantest R6581T. So we select DC voltage, make sure all the settings okay, 110 PLC, 8.5 digits, protection we can disable, ratio we don't have it, autozero enabled. I can even run the internal calibration just to have best result. DCV takes about a couple minutes. So what during the internal calibration, meter is using on 7 volt LTZ reference as a stable known source and calibrate all the other DC voltage ranges like 100 millivolt, 1 volt, 100 volt and 1 kilovolt to match the known value from LTZ reference. The very similar function have implemented in HP meters, but there it's using ultralinear ADC to transfer all the ranges. Unfortunately, ADC in Advantest meter is not that great, and there might be some other issues in this meter, so the transfer is actually slightly worse. Here we are, done. Now we can connect our 10 volts in positive polarity. So you can see, I'll record the value. Plus 10,000,00181 volts. And you can wait 188. Let's call it that. And now I can reverse the jack. And we get -10, 000 around 237 volts. So here is our data, and we can calculate the difference. And that translates around 0.49 ppm delta. We can compare it actually to one of the other meters, just for the sake of completeness. And we can follow the same procedure. So we can use one of guys right over there. Let me adjust the camera just a bit taller. There we go. Good old Keithley 2002. Let me there we go. It's kind of hot today, so we're slightly off. Quite slightly off. Let's just set the speed. And make sure all the other stuff is set right. Alright. The room temperature around 27. So we are about 18 ppm. So we can record that as plus 9998,193, and then the reverse. Minus 999. 8284. So we can calculate that. And we get around 089 ppm. We can check the other 2002. I think it's way too hot for them. The one which sits right over there, right under the light. Sorry about the glare. There we go. Set the speed to 50 mpLC. Nine 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 852. Now we can do the reversal. Wait for a couple samples. We'll get 959s and 40. Let's say 845. Let's see the calculation result. 852. 999. 45. Around the same. 0.93 ppm. And probably just to be completely finished with this, we can do over second one. Second HP meter. Let's go back to down camera. There we go. This guy. I'll show you I connect same terminals. Right over there. And here is our data. That's a lot of 9s over there. Let's say it's 6 9s and 7. We can do the reversal. get so we can calculate this. And we get 0.27. So there we have it, and I think that's it for today, and thank you for watching.